Example 4 will be the hardest one that we'll work on as far as it getting the most messy. And it's the same procedure though. We just have to do some extra steps to clear those fractions first and clean up those equations to set it up the way that we've been doing it so far. And so in the first equation, I want to multiply through by 6. So when I multiply through by 6, I'm going to get 3 times x plus 2 plus 3 times y minus 2 plus 2 times z minus 2 is equal to 24. So that's what I get when I multiply everything by 6. So now if I go ahead and distribute and clean this up, I get 3x plus 6 plus 3y minus 6 plus 2z minus 4 is equal to 24. I want to take all my constants, combine them, and move them to the other side. So the 6 and the minus 6 disappear. And I'm going to add 4 to the other side. So I'm going to get 3x plus 3y plus 2z is equal to 28 now on the other side because I'm going to add 4 to both sides. So this is my new equation 1 after I cleaned it up. Let's go through now and clean up equation 2. So I'm going to multiply equation 2 by 8. So when I multiply through by 8 for equation 2, I'm going to get 4 times x plus 2 plus y plus 6 plus 4 times z plus 1 is equal to 56. Now let's do the same thing. We're going to distribute, clean it up. So I have 4x plus 8 plus y plus 6 plus 4z plus 4 is equal to 56. So I want to take all my constants and subtract them and get it to the other side. So if I take 8 and 6, that's 14. And then plus the 4 gives me 18. So I want to subtract 18 from both sides. So on the other side, I'm going to have 38. And then on the left side, I'm going to have 4x plus y plus 4z. So this is my new equation 2. Okay, let's do the same thing for equation 3 now. Equation 3, let's multiply everything by 12. So that's going to give me a 6 times x minus 2 plus a y plus 10 plus a 2 times z plus 1 is equal to 36. Okay, let's finish this one. When I multiply that out, I get 6x minus 12 plus y plus 10 plus 2z plus 2 is equal to 36. Now I want to get all my constants together over to the other side. I have a negative 12 and a positive 10 and a positive 2. That all disappears. I don't even have to do anything. That gives me a negative 12 and a positive 12. So what I'm left with is 6x plus y plus 2z is equal to 36. So this is my third equation all cleaned up. So now let's take equation 1, 2, and 3 and start eliminating variables. If you look at the new equations in red of 1, 2, and 3, for equations 2 and 3, I just have y. So I'm going to take equation 1 and 2 and eliminate the y. I'm just going to multiply equation 2 by a negative 3. So equation 1, I'm just going to copy down. Equation 2, I'm going to multiply by a negative 3. So I have a negative 12x minus 3y, and that gives me a minus 12z is equal to, and then if I take 38 times a negative 3, that's going to give me a negative 114. This is going to help me develop my equation 4. So the 3y and the minus 3y disappear. When I add the x's, I'm left with a negative 9x. When I add the z's, I'm left with a negative 10z. And when I add the negative 114 plus 28, that's going to give me a negative 86. So there's my equation 4. Let's create my equation 5 now with equation 2 and 3. So I'm going to take equation 2 and multiply through by a negative 1. So I'm going to have a negative 4x minus y minus 4z is equal to negative 38. Then I'm going to copy down equation 3. So I have a 6x plus y plus 2z is equal to 36. And I'm going to add those vertically. So that gives me a 2x. This will give me my equation 5. That will give me a 2x. The y's disappear. I'm left with a minus 2z is equal to a negative 2. So now I have to take equation 4 and equation 5 and eliminate another variable. If you notice, if I take equation 5, so these are the new equations now that I'm dealing with, that I've got it down to a 2 by 2 system now. If I take equation 5 and multiply through by a negative 5, that will give me opposite z coefficients. So let's finish this over here. I'm going to take equation 4 and just copy it down. I'm going to get negative 9x minus 10z is equal to negative 86. Now I'm going to multiply equation 5 by negative 5. So that gives me a negative 10x plus 10z is equal to positive 10. When I add these vertically, the z's disappear, and I'm left with a negative 19x is equal to a negative 76. When I divide both sides by negative 19, that gives me x is 4. So there's my first variable. Phew, this was a big mess. It's not hard, it's just long and tedious. Okay, so now I have to back substitute. I'll take equation 5 and I'll plug in for 4 for x, and I'll be able to find z then. So I'm going to take equation 5 and plug in 4 for x. So that gives me 2 times 4, which is 8, minus 2z is equal to negative 2. I'm going to subtract 8 from both sides, so that gives me a negative 10, and then divide both sides by negative 2, so z is going to be 5. So there's my second variable. And now I'm going to take x is 4 and z is 5 and plug it into one of the 3 equations that I cleaned up at the very beginning so I can solve for y. So let's say I pick equation 3. So I'm looking at this equation right here, equation 3, and I can plug in 4 and 5 for x and z. So let's do this over here. I'll do it in green. That way we can see the different steps. So this is an equation 3 now. I'm going to take 6 times 4, which is 24, plus y, plus 2 times z. Z is 5, so 2 times 5 would be 10, is equal to 36. So I'm going to take 24 and 10. That gives me 34. So I have y plus 34 is equal to 36. And I'm going to subtract from both sides. So I'm going to get y is 2. So my final answer as an ordered triple, my x would be first, then my y, then my z. a big mess, but not hard. It just takes a long time, and it's really easy to make a mistake because there's so many steps. So you really have to take your time. Now, a problem like this, I promise I will not put it on an exam. This is a very long and tedious example. This might show up in your homework as practice, but I won't put something like this on an exam. It will take too much time. Something that you might see on exam as far as the level of difficulty might be something like example 1 or example 2. Okay, now let's go on to special cases. So you're going to approach this the same way you do the other problems. You want to label them equation 1, equation 2, and equation 3. And you're just going to go through the steps like we normally would. So let's say we pick equation 1 and equation 3. So we're going to pick equation 1 and equation 3 maybe. Let's pick equation 1 and equation 3 and eliminate y, since that's already set up where we have opposite coefficients. So I have x minus y plus 3z is equal to 0. Equation 3, I have negative x plus y minus 3z is equal to 0. I'm going to add those up. The x's and the y's disappear, and the z's disappear. So I have the case where 0 is equal to 0. So this is a true statement. So this is going to be the special case where we have infinite solutions. Okay, the next example, here we have equation 1, equation 2, and equation 3. So I have 3x minus y plus 2z is equal to 3 for equation 1. Now, let's use equation 3 because the z's are set up so that they'll be canceled without having to do a whole lot of work. So I'm going to copy down equation 3. So when I add vertically, I get 5x plus 2y is equal to 4. That will be my equation 4. Now I'm going to try to eliminate z again. So let's use equation 2 and 1. Equation 1, I'm going to have to multiply through by 2 so that the z's cancel. So I have 6z minus 2y plus 4z is equal to 6. And then I'm going to carry down equation 2 minus 6x plus 2y minus 4z is equal to negative 8. When I add those vertically, whoops, look what I did. I made that a z. Let me fix it. When I add those vertically, the x's disappear, the y's disappear, and the z's disappear. And I get 0 is equal to negative 2. This is a false statement. So this means no solution.